Okay, let's discuss the volumes of prisms and cylinders. These are the content standards and the mathematical practices. Previously, you found surface areas of prisms and cylinders, and now we're going to find volumes of prisms and volumes of cylinders. Recall that the volume of a solid is the measure of the amount of space the solid encloses. Volume is measured in cubic units. The volume of a prism is found by taking the area of the base times the height. Here we have a triangular prism. So the area of the base would be 10 times 12 divided by 2 times the height of 25. So the volume of this prism is 1,500 cubic centimeters. Okay, time for you to try your hand at volume of a triangular prism. So pause the video and then come back and check your answer. This one required a little bit more work because you don't know what A is. We know what the hypotenuse is, 30, and one leg is 18, so we had to find A. I used the Pythagorean theorem. A is 24. So the area of the base, 1/2 of 24 times 18 is 216. Then substitute that in the volume formula times 15 is equal to 3,240 cubic inches. Like a prism, the volume of a cylinder can be thought of as consisting of layers. For a cylinder, these layers are congruent circular discs, similar to coins in a roll. If we interpret the area of the base as the volume of a 1-unit high layer, and the height of the cylinder is equal to the volume of a layer times the number of layers, or the area of the base times the height. So we're to find the volume of the cylinder to the nearest tenth. The formula for volume of a cylinder, pi r squared h. R is 1 8/10, as well as the height. Okay. Using a calculator, the volume is approximately equal to 18 3/10 cubic centimeters. Okay, check your progress. So pause the video, work this problem, then come back and check your answer. So volume is equal to 8 squared times 5. So 64 times 5 times pi is 1,005 3/10 cubic centimeters. Cavalier's principle: if two solids have the same height h and the same cross-sectional area b at every level, then they have the same volume. So think of a stack of books. You have 3 books. If they're sitting upright, they have the same volume as if they're tilted on a shelf. So that's what that's telling you. So looking at the volume of an oblique solid, we're going to use the formula for a right cylinder. The radius is 15, the height is 25. So the volume is approximately 17,671 5/10 cubic feet. Okay, time to check your progress. So pause the video. Again, we have an oblique cylinder, so we can use the volume pi r squared h. Pause the video, then come back and check your answer. So pi times 11 squared times 44 gives us 16,725 8/10 cubic centimeters. And finally, a standardized test example. Prisms A and B have the same width and height, but different lengths. So they're both, the base is 4 by x, but this one has a length of 5 and this one has a length of 9. If the volume of prism B is 128 cubic inches greater than the volume of prism A, what is the length of each prism? So we know the volume of each solid and that the difference between their volumes is 128 cubic inches. So if the volume of prism A or prism B minus the volume of prism A, the difference is 128. We can write our equation 4x times 9 minus 4x times 5 equals 128. 36x minus 20x is 16x. Now simply solve for x. So the length of each prism is 8 inches. So the correct answer would be B. Okay, time for you to show your stuff and work this standardized test example is similar to the previous example. Pause the video, work the problem, then come back and check your answer. 6x times 11 minus 6x times 7. 66x minus 42x is equal to 192. 24x is equal to 192. Divide both sides by 24. We have 8 inches. Very good. You're ready to begin working the assignment.